Hello everyone, welcome to MentorsMindIAS. I'm Isha Singla and this is the part 2 of the divisibility series. Here I will be discussing the divisibility rule of 7. It is a little uncommon and sometimes asked in the exam, and if you don't know it, it will take a lot of time. Let's discuss this rule. By the end of this video, I will make sure that you are comfortable in it. So there are two ways for the rule of to represent the rule of 7. One is this one and another one is the 3-block digit method. So first I will start with a simple one. In case you have a number say 203. So the first thing you have to do is you have to take the last digit and double it. The unit digit and double it. 3 into 2, 6. Now apart from this unit digit, the remaining number, here it is 20, you have to subtract this doubled number from this. It is if 20 minus 6 is equal to 14. Now, if this number is divisible by 7, then your whole number is divisible by 7 too. 14 is divisible by 7, therefore 203 is also divisible by 7. Now, let us take another example. For example, 343. This is a 7 cube. So, I know it is already divisible by 7. So, if in this case, again, 343, you have to take the unit digit and double it. 3 into 2, which is equal to 6. And now the remaining number, 34. 34 minus 6 is equal to 28, which is divisible by 7. 7 into 4 is 28. Therefore, 343 is divisible by 7. You need not do the whole division. It can be simply solved by this method. So, double the last digit and subtract it from the remaining truncated number. Check the divisibility by 7. You will get an answer. If in case you have a very, very large number, say 3, 4, 7, 8, 2, 5, 6, 7, 9, 3. Now, this is a number. You have to check its divisibility, say 7. If you use this rule, you will double it 3 into 2. Now again you will be subtracting and you will be checking the numbers divisibility, again the last digit. So it will take a lot of time. It is not, basically it is not feasible. It is feasible, but it is not very useful in the exam in case you have large numbers. So for this large number, there is another method, that is a 3-digit block method, which I will be explaining next. Here the number is very large. 45 4 5 3 7 0 5 4 2. Now how to do this? It's simple. The 3-digit block method, 4 5 3 7 0 5 4 2. Starts from the unit digit and divide into 3-digit blocks. I'm labeling it. You have to start with the unit digit so that you don't make a mistake. Most of the things in this is done from the unit digit only. From the now this is your block B1. I'm labeling them B2, B3. Now you have to do alternate sum. That is, you have to do subtraction, then addition, subtraction. So now 542. First is the subtraction one. 542 minus 370. Now you have done. Now you have to add the third block, 0, 4, 5. In here it is 3-digit, less than 3-digit, right? So you can add a 0. It does not, but it will not affect it. It is just to make sure that you understand it, that it is 3-digit blocks. 542 minus 370 plus 45. The answer is 217. Now you have to check its divisibility. If it is divisible by 7, then this whole number is also divisible by 7. If it is not divisible by 7, then this number is also not divisible by 7. So when you divide it by 7, your answer is 31. There is no remainder. So since 217 is divisible by 7, the original number, this is also divisible by 7. It's simple, right? You had listed the whole process in the next slide too. First, group the digits. You have a large number of 3-digit blocks. Make the 3-digit blocks. The leftmost this block might have fewer than 3 digits. Now calculate the alternative sum. Start with subtraction. Say it is B1, B2, B3, B4. So B1 minus B2 plus B3. Now already now plus, now minus B4 and so on. Say you call it S. I've already written S. Now check for divisibility. If that S is divisible by 7, then the original number is also divisible by 7. Simple. So now I'll be applying this 3-digit block method in a question of the previous year 2021 UPSC question. So this is the UPSC 2021 CSAT question asked in prelims. So in this case, you have the number 3. You have the number 3798125P. 369 is divisible by 7. You have to find the value of that digit. So basically, you have to make sure this whole number with that value of P should be divisible by 7. So you will be using the divisibility rule method here. 3798125P. 3698. So you start with 3. I'm making first step is making 3-digit blocks. So I have 4 blocks: 037 981 225P 369. Now this is B4. Label it from here: B1, B2, B3, B4. Now find the sum S, alternating sum. So B1 first is minus B2 plus B3 minus B4. B1 is 369 minus 25P plus 981 minus 37. Now This 25p can also be written as 250 plus p, just like 105 can be written as 100 plus 5. So this is also some 250 plus something. So when you then the final expression, so what your final expression is 369 minus 250 plus p plus 981 minus 37. This can be, so basically it is 369 minus 250 minus p plus 981 minus 37. This, when you solve this, you get 1063 minus p. This is s. Now s needs to be divisible by 7, so we have to subtract something from p value from 1063 such that it becomes divisible by 7. But to find that p value, you have to check the divisibility is 7 1, right? Break this number. Basically, you need to divide it by 7. So when you divide it, if you divide it, you will get the quotient 151, and your remainder will be 6. So that means 151 into 7 plus 6 is equal to 1063. If we subtract 6 from this 1060, your what will it will be 157 into 7. So then this means that p is equal to 6, because 1063 minus 6 is equal to 151 into 7, which is equal to 1057, which will be fully divisible by 7, and so your s will become fully divisible by 7. This number will thus become fully divisible by 7. So you have to simply what the value is, 1063 minus 6 is equal to 1057, which is divisible by 7. So if you choose the value of p6, your whole number will become divisible by 7. So this was all about this digit 7 divisibility rule. Thanks for watching. Watch part 1 in case you have missed it, and there are also more videos I have uploaded about LCM remainder theorem and other shortcuts and tricks which are used in UPS and all other CSAT papers. Thanks for watching, and please do subscribe to the channel for more updates.